Now, and so from the graph, for example, that we know, of course, in problems, in homework, you know what P is, right? We know what is P, but we don't know whether we have this part or we have this part. We don't know whether we have no motion or we have motion, or we have motion impending. So what should we do? We need to assume something first. We need to assume something first. We need to assume something first. So what do we assume? Should we assume there is motion or should we assume there is no motion? In doing these problems, in working on these problems, we first assume no motion. And that is summation f equal to 0. And we determine f and r. Oops. A minute. Oops. And wait a minute. We want to determine f and r. Now, after that we determine and we calculate. After we determine r, we determine, what can we determine? We can determine mu s times r, which is the maximum friction. We want to determine whether it is moving. So we first assume there is no motion and we determine f and r. To determine r, because we want to determine mu s times r, which is the maximum friction. So if we have no motion, if f is smaller than mu s times r, it means we have no motion. Let's go to the last. Let me write down everything. And if f is larger than mu s times r, which is impossible, and so the assumption is wrong. So we have motion, and we need to recalculate the f is equal to mu k times r. So let's have a quick look of the chart. Here that if we have motion, the friction is P is larger than F, and F is equal to mu K times R. It's okay. Here. We assume, because we don't know we have motion, or we have no motion. Because we don't know we have motion, or we have no motion. And our SOP looks like this, that we first assume we have no motion, and determine F, R, and mu S times R. So if our assumption is correct, sorry, that's now. So we have we calculate the we assume we calculate the mu S times R. If should I put the graph here? On the right hand side, on the left hand side, it means F equal to mu s times r. It means the F here, F is this one. So we have no motion. But on the right, we have F is larger than mu s times r, which is F is here. That means this is impossible because we need a very high friction to keep it at rest. So we need to have so it means we have motion. That is we calculate F is equal to mu k times r. Here before we end today's lecture, so we have I think on page 436 we have something like this, but I'm not this from the old version, but 436. Right, and so there is a long group of there's a long paragraph of English here. So how do we read this? So we read the first sentence. Most problems involving friction fall into one of the following three groups. 三组哈。So in three groups, it means we have 1, 2, and 3. So where is the first group? The first group is here, and the second group is here, and the third group is here. So, and for problem, that you will have something which are known, and then we need to determine something, right? Something unknown, and we want to determine something, and given, which is known, and then we added known and given, and we determine something. Okay, so that's then you know what is given, what is known, and then we determine something. Now the rest here is the procedure. So this describes what I have drawn above. For example, that calculate this one, and we get these two cases, right? So if F is smaller than mu s times r, that there is no motion. If F is larger than mu s times r, we have motion. So in this passage, we have if F is smaller than, or if F is larger than. It's okay. Sorry.